Alright class, so this lesson again is very similar to the one before, the video before, except for it's with cosine curves. But before that happens, I just wanted to put this up here. This is the review from yesterday. The only thing you have to remember is that before you can talk about the phase shift, you have to factor out the frequency, which changes the phase shift to pi over 4 to the right. And remember, the period of one cycle is just 2 pi over the frequency, or it's 360 over the frequency. Okay, so let's go on to cosine curves. So just like yesterday, we still have these coordinates for our unit circle. And we have these angles. Okay, so if I'm graphing theta versus the cosine of theta, we have all of our favorite spots. And we know that cosine can go from 1 to -1. So remember, cosine is like the x value of a unit circle. So we're looking at these values to plot. So when the angle is 0, we're up at 1. When we're at pi over 2, we're at 0. When we're at pi, cosine is -1, 0, and 1. So this is what a cosine curve looks like. Oh, kind of messed that one up. Notice how the cosine curve normally starts at the top of, or the crest, the highest point, the maximum. That's the big difference between that and sine. The period's 2 pi and the amplitude is 1. Okay? Again, just like yesterday, everything is the exact same thing as it was before. So this is the amplitude. This is the frequency. C is the phase shift, which is our horizontal shift. And then this is the vertical shift, or the node. Okay, so pretty much everything we're going to do right now is the exact same as yesterday. Okay, so the first thing I do is find out where my node is. The node is at y equals 5. And then the crest and trough go up and down 3 from there. So 5 plus 3 is 8. 5 minus 3 is 2. Then I know that the period is normally between 0 and 2 pi. Okay. And I can then solve for x to find out my shifts. So first we multiply by the frequency. Well, we divide by the frequency, which is like multiplying by 4. So now we know the period of this cycle is actually 8 pi. And then if we shift it pi to the left, we get x is between -pi and 7 pi. We also know that our interval is going to be the period divided by 4, because there's 4 sections, so it's going to be 2 pi. Okay, so I'm going to start off with this axis first and say that I'm at -pi and then 7 pi. I have a middle piece, a middle piece, middle piece. And then we just found out that the interval is 2 pi. So plus 2 pi gets me to pi, plus 2 pi gets me to 3 pi, plus 2 pi gets me to 5 pi, and sure enough, you did it right if plus 2 pi gets you to 7 pi. We have our, at 0, the line. The highest point is 8, the middle point is 5, the lowest point is 2. I make my box. So this is going to encompass the one cycle that I want to deal with today. And again, so everything I just did is the same thing we did on the sine curve. Except for now, we know that after all the shifts are applied, cosine always starts at the top unless there's a reflection. But there's no reflection here. So we go top, middle, bottom. So upside down, right side up, upside down. So there's our curve. Okay? If you guys get this, you should probably pause the video and try the next two on your own, just to see if you can do it. Some things to note, though, on number 3. The first thing is we're in degrees, so that changes what you set your inequality up between. And the second thing is we do have a negative in front, which reflects the curve. So I'll talk about that as I go. So this one here, the node is at y equals -1. The crest and trough go up and down 2 from -1, so we go up to 1 and down to -3. We're going to set up our inequality. This whole thing should be normally between 0 and 360 degrees. Again, I'm in degree mode. Divide by 9. and I get x plus 30 degrees equals 40 degrees. This is the period of this, because there are 9 cycles in 360. And then finally we do a shift. So the graph will go between negative 30 and 10, and it will go up by an interval of 10 degrees. So here we go. I have negative 30, I have 10 degrees, degrees. Make sure you put degrees on there because radians can be numbers too, and you would, it implies it's radians if you don't have the degree symbol. So negative 20 degrees, negative 10 degrees, 0 degrees, and 10 degrees. So here's the axes. We're going up 1, 0, negative 1, negative 2, negative 3. So 1, negative 1, negative 3. And that'll determine the box. So the box goes here. And again, the only thing that's different about this one is it is a reflected curve, which means it reflects over the node line before the shift normally. So it starts on the bottom. So cosine either starts on the top or the bottom, and sine will always start in the middle, and then you have to decide which way you're going to go. So this is an upside down cosine curve. All right, we got one more. Notice how number 4 has no plus or minus at the end, which means that the node is the center line is at y equals 0. So there's no shift, which means the crest and trough is just the amplitude. It's going to go up to root 2 and it's going to go down to negative root 2 because there's no vertical shift. I'm in radians again, so I have to put that to 2 pi. If you multiply everything by 6, I don't know why I have a parenthesis there, you shouldn't need it. You get 12 pi as the period. Then you do the shift, we're adding pi over 2. To add pi over 2 to that, that's like 24 halves, so it'd be 25 pi over 2. Okay? And then the interval is 12 pi divided by 4, which is 3 pi. Now, because I'm looking at the start and end points and I notice that they're in halves, I'm going to turn 3 pi into 6 pi over 2. It's the same thing, right? It's just the fraction with a denominator of 2 on the bottom. So, I'm starting at pi over 2. I'm ending at 25 pi over 2. I have a middle, then a middle, middle. My interval is 6 pi over 2, so 1 pi over 2 plus 6 is 7 pi over 2. Okay. 13 pi over 2, 19 pi over 2, and 25 pi over 2. And then we can make our actual axes. Since the center line is that, here I'm just going to say it's over here. The node is here. The top is root 2. The bottom is negative root 2. And then the box starts here because we're going from from pi over 2 to 25 pi over 2. So there's my box. Again, it's cosine positive, so I start at the top and then you go down back up. And there's the curve. So, same thing as sine curves except for where you start. Okay? Alright, that's it.